You can?
Yes, ma'am.
Tell me, what do you know about limits? You said you're self-reading the PIP subtopic, right? So let me get whether you have understood the concept of limit
Yes.
right. What do you know about limit? Can
Ma'am,
you tell
limit
me
is
what
where
you understood about limit?
yes, ma'am. Ma'am, limit is the value where that prevents it from achieving, from reaching a certain value.
Okay,
Ma'am,
can you explain it further?
yes, ma'am. Ma'am, if fx is equal to x, x is like x is reaching zero, then it cannot. Then the value stops it from going beyond that.
Okay, so I'll give you a
Ma'am, you're breaking up.
suppose if you have a function, say, is it clear? Yeah. Yes, sir. Yes, sir, I can hear you. Uh, Mine is at the perfect speed, sir. It's 212 Mbps per second. I'm checking the speed correspondingly. Yeah, I'll rejoin. Yeah, I'll rejoin, sir. Represent this file, graph like this.
Yes, ma'am.
Okay, and there is a gap over it. I'm marking the gap with a circle. Okay, just for the understanding. And the function goes on like this. Okay, this function, suppose let this be f of x, and this corresponding point, let's say, be like somewhere around 3.
Yes, ma'am.
Okay, so what the limit actually does is, so limit has two concepts. One is your right hand limit.
And left hand, ma'am.
Yeah, so what is the right hand limit?
Ma'am, the one with the positive value, ma'am, the plus.
Okay, can you just tell me from the graph how can you approach the left right hand limit?
The right hand limit past the will be past the point of reference, the value of the limit, like 3 in this case. So in this case, after 3 would be the value of the right hand limit.
Yeah, the value of the right hand limit is fine. So the concept is actually like the what is way. I'll change the color for you. Suppose this entire graph is a function, right? This entire point is a function for us in our
Yes,
assumption. We have to approach from our right hand side, this point, the right hand end. Okay, so we'll have to keep on approaching the function, and here we get a break before we move ahead, right?
yes,
So this point which we achieve from the right hand side of the function will be your right hand limit. So this is generally denoted by fx plus. Okay.
yes, ma'am.
Similarly, when we approach the graph from our left hand side, we can keep on going till we get that breaking point of the graph. So this will be your fx minus, which is your left hand limit. So in general, when you approach from the right hand side of the function, that will give you the right hand limit. When you approach from the left hand side, that will give you the left hand limit. So what the concept of limit is actually, this graph seems to be a smaller one. So when you zoom in, what we want to say is, this is your x value, right?
Yes,
This is our point 3 under consideration. So we are speaking from the right hand side of the 3, we are approaching towards this 3. Okay.
yes,
The gap is like that 3 plus some x naught. This x naught is very negligible.
yes,
Very, very negligible. We would say this as a neighborhood. Okay. We are taking a point from the neighborhood. Neighborhood is nothing but the points which lies very closely to the point 3. So what happens to the function value when x plus x is replaced by 3 plus x naught? That is what gives you the right hand limit. This x naught can be very negligible. This x naught is considered to be less than some epsilon. Epsilon is usually a representation to give the negligible value. Okay,
Yes.
so we can't zoom in. So in if you want to zoom the number line, just to say the very next point of 3, what happens to the function? All those kinds of values will come under the right hand limit. Okay.
Yeah.
Similarly, when you approach from the left hand side, this 3 minus x naught. Similarly, the x naught is the same negligible value. Very small, tiniest difference is there between 3 and 3 minus x naught. Very, very close to 3. Okay. So what happens to this function value f of 3 minus x naught is what deals with the left hand limit.
Yes.
Okay. So what happens to for a function? I said there are two limits, right hand limit and left hand limit. What is the limit for the function? There are two limits, right? What is the limit of the function? What happens here is, I'll give you one more graph for an example. Suppose your graph is going like this. This is your point number 2. This is a point 2. And this is your point 2. Okay.
Yes.
So what happens here to the graph?
Then right hand limit will be uh, right hand limit will be 2 minus 3.
No, the limit does not speak about the 2 minus 3. What happens to the limit here is, we are talking about, this is a graph, right?
Yes.
I'll change the color for you. So this is our graph. Okay, we are approaching the graph from our left hand side. What happens here? If we keep on moving, the graph is continuous. We get a value for every x where x is less than 2. Right? This is the notation, right? For every value x less than 2, from let's say the graph starts from 0. From 0 to 2, we have a value. At 2, the function, what does this dot means actually?
It's the it's the origin point. It's like where
No, it's not the origin point. This
I mean
is this.
not the origin point. I meant like the marking between the left and right
No,
side.
no, no, that is not the point here. So what happens here is, this says that f of x, the function, what do you have? F of x is not defined at this point. What do you mean by not defined?
There is no true value for it.
What do you mean there is no true value? So suppose if you take an example of, is this function defined everywhere? 1 by x minus 1.
No,
So where is this not defined?
1 by 1 minus 1.
So when x is not equals to 1, the function is valid. The function is defined. At the point where x equals to 1, this function is not defined, right?
Yes,
So why do we say that the function is not defined at x equals to 1?
because 1 by 0 is equal to undefined.
Yeah, similarly the same way, at this point the function doesn't have a definite value. Okay, so that
Yes.
is the marking point. Similarly, the above example, above graph, this does not give you the origin point or something like this. At this point, at 3, the function f of x is not defined.
Yes.
Okay, this is what this point is there, right? This marking point. This says this function f is not defined at x equals 3. So limit always deals with the value where the function value is not defined. There is the old concept of limit, the broader concept. Okay.
Yes.
So when suppose if you have a function, say x equals to f of x equals root x, what do you do to find the value? If you keep on putting values for x, all the positive values, you'll get the value, right?
Yes.
The given condition must be x belonging to R. You know this notation, right?
Yes.
So, So whenever the x is belonging to R and x is positive or 0, the function is valued. Function has a value. What happens to the negative value x? There comes the concept of complex number, right?
Yes, ma'am.
Understood?
Yes.
Similarly, so whenever the function is not defined in a particular domain we are speaking about, but we have a certain point, let's say like here, for example, at 3, the function is not defined. Okay, everywhere else, say from here to here, everywhere the function is defined except at this point. Okay,
Okay.
at 3. So what do we should we omit the entire function with this within this interval? No, we can't omit it. We have to study the function. But we can't study the function at 3, x equals to 3. That's where the concept of limit comes in. The function is defined everywhere within this interval except 3. So in general, we'll study about the function and the particular interval and specially study what happens when x takes the value of 3. That particular study deals with the limit concept. Okay. So if you want to have a general notation, I can explain you generally without giving any particular example. Let's say this is your graph. This is your point A. Okay. This is your x-axis and this is your y-axis. Y equals f of x. Your graph goes on like this. This point, okay. So what happens here is this is your A. Sorry, once again. So this is your particular x and this point, let's say this is your x plus h. This h is nothing but your smallest addition to the value of x, smallest negligible neighborhood. Okay. Similarly,
Yes.
this point can be x minus x. Okay.
Yes, ma'am.
So we speak about what happens at all the 3 points. What happens to f of x minus h? What happens to f of x? Sorry, this will be a f of x at a, f of x plus h. Okay, this x is nothing but common a. Okay, so here in general, what happens here is x minus h is the smallest neighborhood, right? So when we approach from this side, what happens at x minus h? There is a definite value. Here we have a value, right? This one. This is our x minus h. So when you move again, can you see a point on the graph? The function is there. Function is defined, right?
Yes, ma'am.
So what happens when you increase the value of h? So as you move closer to this point, the function becomes undefined.
Yes, ma'am.
Similarly, when you move from this side, at x plus h, here you have a value. As you move closer to x, somewhere very close, the function becomes undefined. Okay, the limit function is equals to limit of x equals to f of x plus h minus f of x by h. This is what the general notation is. Okay,
Okay.
this happens only when both the right hand limit and left hand limit are equal.
Okay.
Okay, here we spoke about right hand limit to be a positive and left hand to be the negative. It's not literally the positive and the negative. It just means towards the positive side and towards the negative side. Okay. The value
Yes,
of
ma'am.
x is not positive and value of x is not negative for left hand limit. It just means to say that the value of x takes place towards the positive side from the origin and f of x minus takes the value of x towards the negative side of the origin. That's what they imply. That doesn't mean that sign is positive or negative. Okay, the value is not either positive or negative. We just mean
Yes.
that which side the limit goes on. Okay, you
Okay.
understood the difference? Yeah. So here, if you want the left hand right hand limit notation, it will be f of x plus equals f of x plus h minus f of x by h. Okay. Limit f of x minus will be equals to x minus h minus f of x by h. Why do we take negative here? Because we are reducing the value from x, right? We are moving this side. We are moving from this side to x, which has the lesser value compared to x. So we have the x minus h here. This right hand side, we are moving from the positive side. The next value will be something greater than x, right? Here. This point will be greater than 3. This point will be greater than 3. This point is greater than 3. This point is greater than 3. All these all comes under the right hand limit. So we are adding the h. H is the difference here between 3 and this point. 3 and this point. 3 and this point. All these the difference. That is the h. You understood? Ethan, are you there? Ethan?
Hello, ma'am.
Yeah. So, did you understand what I was telling you?
Yes, ma'am.
Okay. So we have this plus h and minus h because we are adding the value to the point 3 here. This one. Okay, to get this next point, we are adding some value. So that's why we are having x plus h on the right hand limit formula.
Yes, ma'am.
Okay. Similarly, on the left hand formula, we have this x minus h is because we are reducing some value from the 3 to get this point, this corresponding point, this point, this point, or all less than 3. We are subtracting some values from the 3. This is the h distance.
Okay, ma'am.
Okay.
Yes.
Yeah. So when both f of x plus equals to f of x minus, sorry, and I'm sorry, I left a main point here. This h must tends to 0. This will be notation. So what does it mean? Means as much as you go smaller with the value of h, this has to be true. This h can be 100, this h can be 50, this h can be 0.1, point not 1. Like the most, it should be closer to 0. So
Yes.
that's what they mean to say here by adding the notation of h tends to 0. This symbol h arm of 0 means the h tends to 0, which means h is moving towards 0. Okay?
Yes, ma'am.
Okay. So when the right hand limit f of x plus h tending to 0 equals f of x minus h tending to 0 is equal, then we say limit exists for the function. Suppose if this is equal to say some a, then we say f of x h tending to 0 equals to a. When this is not true, when right hand limit and left hand limit are different, then we say either right hand limit exists, left hand limit exists. We don't say the limit exists for the function. The limit exists for the function only when both right hand limit and left hand limit exist and they are equal.
Yes, ma'am.
Okay, you understood the concept of limit so far?
Yes, ma'am.
Okay. What happens to the continuity here is if the graph doesn't have any break like this point is there, right? I'll- yeah. Here, if you notice, this point is there, right?
Yes, ma'am.
When this kind of break is not there on the graph and it's continuous, we say that the graph function is continuous.
Okay.
Okay, there are
Yes.
different types of continuous.
Yes.
Okay, there are like discontinuities also there, piecewise continuous is there, uniform continuous is there, all these are there.
Yes.
Okay, so can you tell me what you understood about the limit so far?
And limit, there are two types of limits: the right hand limit and the left hand limit. And then the left hand limit is denoted by fx minus, and then the right hand limit is fx positive, and then the left hand limit, and then the middle, and then the point where fx is not defined, that's in the center sort of somewhere. Uh, that little point, that little circle, that's called fx. That's where the fx is not defined. That is where the two sides are building up to. The negatives are increasing over there, and the positives are decreasing over there, and they join up in the middle where it's not defined.
Okay, as you were speaking, this graph need not join, you said like joining point, right? The
Yes,
graph need not join. See here, for example, the graph is not joining at the point 2.
yes,
Okay, the somewhere like let's say this point can be like your this corresponding point can be like 4, this corresponding point can be like 6. Okay,
yes,
here what happens here is, if you look at this graph, the graph is not joining at the point where f of x meets at 2. If you take the example of left hand limit, this is a left hand limit, right? When you,
yes,
I'll change the color for your understanding. So this will be your left hand limit this way. So you are approaching, the graph starts from 0, let's assume. So you are approaching from 0 till this point. You are approaching. Okay. So as
yes,
soon as we approach x equals to 2, you get a undefined point.
yes.
Okay. So what happens? What is the right and left hand limit here? Value. What is the value?
Two. I mean, it's
No. At 2, what do we speak is, so we will be considering our x here. X will be 2, closer to 2. Okay,
yes,
so as we move from 0 to the point x equals to 2, as we move closer ahead, like this one. So if you move from your point, this point, I'll take a different curve for you. Yeah. So as you move ahead from this point, you're moving. Okay. You're approaching 2 from your left hand side.
yes,
Okay. As you move towards 2, the function gets break. The function becomes undefined at x equals to 2. Here,
yes,
what happens is the function is not defined at x2. So what happens to the value of x minus h? That approaches this point. This limit, what do you say is this value is there now, right? A,
yes, ma'am.
this value we have to A. So this doesn't mean the function is equal to A. This means the function is approaching A. It's not the exact value of A. This is not the
Okay.
exact value of the function. We say the function approaches A. There is a difference between the function value is equal to A and the function value is approaching A. Did you understand the difference?
Yes, ma'am.
Okay. So here the function value seems to approach 4. I have marked this point as my 4 here. This point I have marked like I have assumed it to be 4. Okay. So we say x